Hi, welcome to NewTech YouTube channel. In this video, we are going to study and solve example on duality in electric circuits. Let's begin. In order to construct the dual of given circuit, we are obtaining mesh or nodal equations along with nodes and reference node. In this video, we are obtaining dual of given electric network by graphical method. Now, study some important key terms. First key term, node statement, a point at which two or more elements have a common connection. Refer the diagram. It having two nodes, node 1 and node 2, connected by an element, that is resistance. Second key term, branch statement, a single path in a network composed of simple element and node at each end of that element. In a diagram, resistance between node 1 and node 2 form a branch. Third key term, loop statement, if the node at which we started is the same as the node on which we ended. Fourth key term, dual statement, a relationship is formed by interchanging voltage and current in the network. We just studied some important key terms which are useful in analysis of dual electric circuits. Now see statement of dual concept in electric circuits as statement. Two circuits are exact duals if the mesh equation of one circuit is numerically identical with the corresponding nodal equation of the other. Means, for duality check, we have to obtain the mesh and nodal equation of given circuit and it must be numerically identical. In this video, we are using simple graphical method for obtaining dual of electric circuits. Let's see some dual conversions in mesh and node equations as point 1. Number of loop currents are duals of number of node pair voltages. Point 2. Voltage source is a dual of current source. Point 3. Loop comprising of several branches are dual of node pairs joining the same number of branches. Point 4. If switch is open circuited, its dual as switch must be closed. Point 5. Resistance is a dual of conductance. And point 6. Inductance is a dual of capacitance. Now see duality examples in electric circuits. Point 1. Parallel circuit is a dual of series circuit. Point 2. Short circuit is a dual of open circuit. Point 3. KCL is a dual of KVL. Point 4. Impedance is a dual of admittance. Point 5. Thevenin's theorem is a dual of Norton's theorem. And point 6. Reactance is a dual of susceptance. Up till now, we have studied important key terms, statement of duality concept and dual conversions with examples. Let's study procedure of duality in electric circuits. Step 1. Identify the independent loops in a given network. Then establish node inside each independent loop with a reference node and also label the same. Procedure step 2. Trace each element in network and connect nodes with reference node and label the paths as 1, 2, 3, etc. Procedure step 3. Draw dual network table using its paths from step 2. Procedure step 4. Draw dual network using table from step 3. Using procedure of duality in electric circuits, let's solve example on the same. Example statement. Construct dual of the following circuit. Let's see given data. 10 volt voltage source. Resistance R1 is equal to 3 ohm. R2 is equal to 5 ohm. Capacitor C is equal to 8 farad. And inductor L is equal to 4 Henry. Solution step 1. Refer the circuit diagram. The given circuit having two independent loops as loop 1 formed by 10 volt source resistance R1 and inductor L, and loop 2 formed by inductor L, capacitor C and resistance R2. Then establish node M in loop 1 and node N in loop 2 with node R as a reference node. Solution step 2. Trace each element as resistance R1 is connected between node M and reference node. 10 volt voltage source is connected between node M and reference node. Inductor L connected between node M and node N. Capacitor C is connected between node N and reference node. And resistance R2 is connected between node N and reference node. Solution step 3. Refer the circuit diagram along with trace paths of each elements from step 2. Now draw dual circuit elements table as path 1 from reference node to node M. Resistance R1 of 3 ohm gives its dual as a conductance G1 of 3 Siemens. Path 2 from reference node to node M. 10 volt voltage source gives its dual as a 10 ampere current source. Path 3 from node M to node N. 4 Henry inductor gives its dual as a 4 farad capacitor. Path 4 from reference node to node N. 8 farad capacitor gives its dual as a 8 Henry inductor. And path 5 from reference node to node N. Resistance R2 of 5 ohm gives its dual as a conductance G2 of 5 Siemens. Solution step 4. Let's draw the dual network using table from step 3 as refer the diagram. 10 ampere current source and G1 conductance connected between node M and reference node. 8 Henry inductance and G2 conductance connected between node N and reference node, and also 4 farad capacitor connected between node M and node N respectively. Just review. In this video we have studied some important key terms, statement and procedure of duality in electric circuit, and then solved example on the same. Thanks for watching my YouTube channel. Thank you.